Hi everyone, so in this lab we are going to be looking at the magnetic field lines of different types of magnets. Now what we have right in front of you is a piece of plexiglass that has oil suspended iron filings. And the reason why we use the oil suspension is because then the iron filings can move around the bar magnets and the horseshoe magnets and can mimic the field lines. So we're going to get started with our first example. As you can see, right, the moment we put the bar magnet on top of the iron filings, we saw pieces of iron be attracted to the poles, north and south pole. And I'm just going to tap. And as I'm tapping, I can see the formation of arches. So I see that I have arches on the top, and I also have arches on the bottom. So what I have to basically now do is find where my field line direction is going. And to do that, I'm using compasses. Now, compasses have, as you can see right here, a red and a white side. The white part of the compass is the magnetic south part of the compass, and the red is the magnetic north part of the compass. And the compass needle is always going to point towards south. So if I put it, I can see that the red part of the compass needle is pointing towards the south pole. If I put another compass on the north end, I can see that the red part is pointing away from the north end. And if I put my two other compass needles in the two other positions, I can always see that the red part of my compass needle is pointing towards the south. The red part of the compass needle is pointing towards the south. So if I'm looking at the general direction of my field lines here, I can see that it is pointing away from north. And as I bring it closer to the south, I can see that my compass moves towards the south. Okay, so now we're going to do the horseshoe magnet. Now if you'll notice with the horseshoe magnet, I'm going to tap it again, we have some beautiful arches, right? From the top end of the horseshoe, the north end, going towards the south end. We have beautiful arches. Tapping, tapping, tapping. So our iron filings fall in our magnetic field. And I can also see that I have arches in between, because not only do I have magnetic field lines at the tip, but I also have magnetic field lines in the middle. So if we put our trusty compass, we can see that the red needle is pointing towards south, and it is pointing away from north. And if we were to draw our direction on our field lines, it would be leaving north, and as it's going towards south, it is now the red line pointing towards south. So again, we would have the red pointing away from north, and as it is going closer and closer to south, the arrow direction is going towards south. So that is our horseshoe magnet. Okay, so now we're going to be looking at the interaction between two bar magnets, and the first we are going to have is the south end of one bar magnet here, and the north end of another bar magnet here. Now if we'll notice, I'm just going to move it so we can see that we have field lines in between our two ends of the magnet, which makes sense because the north end of a magnet will be attracting the south end of the magnet, and we can see that they're opposite magnets, so opposite will attract. We put our compass needles, we can see that they are leaving the north and pointing towards the south. So the red part of the compass needle is pointing towards the south. The white part of the compass needle is pointing towards the north. So that's basically showing an attraction. I have the field lines in between, leaving north and pointing towards south. And I can also see that I would have field lines, going around the actual magnet itself. And again, the red part of the compass pointing towards the south on both sides. And we can see the red part of the compass, again, pointing towards south on both sides. Now we're going to flip it, and we're going to show a repulsion. We can see, it's not behaving very well. We can see very clearly that there is no field lines in between our two poles, and that the field lines are actually moving away from one another, so that our arcs are moving away from each other. And I can see, again, we have beautiful arcs around each of the bar magnets, but we're going to reset this up so we can see this really well. We can see it's acting as a repulsion, and that all the field lines are pushing away from one another. And when we put our compass needles, as we predict, our red compass needles are moving away and are pointing in the direction of south. Now we're going to have our last scenario where we're going to have we can see that they're attracting. Behave, that would be wonderful. Oh, hold on a second. Can't even set this up before they start moving towards each other. I'm gonna have to put some distance in between. We can see that we have field lines. Just gonna tap, trying to tap the mass in the middle. Oh, hold on a second. Let's reset this up. The Etch-a-Sketch of Science. Shake it. We can see quite clearly that the bar magnets are not behaving, but we can see, okay, I'm just going to have to actually hold them. We can see that we have field lines leaving from the we can see that we have field lines going in between the magnets, that we have strong field lines between the north and the south pole and the south and north pole of our two bar magnets. We can also see that we have arches in the middle, because again, we are going to have field lines in between the magnet itself going to the different parts. And if I put my compass, which I'm trying very hard to, right, I can see that as it's going closer to the south, the red is pointing towards the south. Now if I move to the other side, right, at north, the white part of the compass is pointing away. As I'm going towards south, it is pointing towards. Same thing also if I'm going around my bar magnet. Here I see that my compass needle is pointing towards south. And as I make my way around, it inverts and the red points away. So that is our magnetic field lines lab. And make sure that you draw all of the field lines and the directions on the lab document and hand it in. Thanks for watching.